In this video, I'm going to recreate a faceting design by Mark Oros called the Three Muses using GemSim. Let's start in the print panel. I'll enter the design name, the Three Muses, and the author, Mark Oros. Notice that this information also appears in the top left corner of the 3D viewport. I'll also enter the date and the website link as a comment. All of this information will be included in the PDF when we print the finished design later. Now let's switch to the geometry panel. This design uses a 72 index gear, so the first thing I'll do is change the gear index to 72. Click Add Tier to create the first pavilion tier, P1. Set the angle to 53 degrees. Next, we need to create the indices. This is a 9-fold symmetric design. Set the base index to 72 and set the symmetry to 9. GemSim automatically distributes the 9 facets around the stone. Click OK to confirm the indices. Next, click Depth. The gray plane in the viewport represents the cutting surface. As I reduce the depth, you can see the cutting surface moving closer to the gem. I'll keep adjusting it until all 9 facets meet at a single point in the center. At this point, it looks like there may not be enough material left for the crown. So I'll increase the size of the rough along the y-axis to give us some additional material. Now let's create the second tier, which is the girdle. The girdle uses the same indices as P1. When I select girdle as the tier type, GemSim automatically sets the angle to 90 degrees. Since a girdle must be vertical, this angle cannot be changed. We also don't need to create the indices again. I can simply select the index set that I created for P1. When setting the depth, I'll adjust it until all of the girdle facets meet each other. You can also add notes to individual tiers. These notes are useful for recording special cutting instructions, and they'll be included in the printed diagram later. Now I'll follow the same basic workflow to create P2 and P3. For each tier, set the angle, choose or create the indices, and then set the cutting depth. There's another useful setting here called granularity. Granularity controls the resolution of the sliders. For example, all of the angles in this design are integer values. So in the angle editor, I'll set the granularity to 1. That makes it much easier to quickly select exact whole number angles. When setting the cutting depth, a common faceting workflow is to use a meet point instead of adjusting the depth manually. For example, P3 is supposed to meet P1 and P2. I'll select the existing intersection point between P1 and P2. As soon as I select that point, GemSim automatically moves the cutting surface so that the new facets cut directly through it. With the pavilion finished, we can move on to the crown. The workflow is exactly the same. Create a crown tier, set its angle, set the indices, and then determine the depth by selecting the appropriate meet point. Then repeat the process for the remaining crown tiers. Most of the index sets can be generated using symmetry or reused from tiers we already created, but C3 only has 3 indices. For something this simple, I'll just type the 3 index numbers directly. Sometimes it may not be obvious which existing point should be used as the meet point. In that case, I can switch back to manual depth adjustment and use a smaller granularity. Then I can slowly move the cutting surface and watch how the facets change until I find the correct position. Now the cutting geometry is complete. This design also includes frosted facets. There are 2 ways to mark them in GemSim. If an entire tier should be frosted, simply click the frost icon for that tier in the tier table. You can also frost individual facets. Select a facet directly in the 3D viewport, then click the frost icon in the tool belt. GemSim makes the frosted facets easy to identify. They're shown in light blue in the 3D viewport, and their index numbers are displayed with a gray background. Now let's switch to the render panel. Here we can see a more realistic preview of the finished gemstone. We can also experiment with different materials. For example, I can render the design as sapphire, emerald, or another gemstone material and see how the appearance changes. This is a useful way to preview a design before committing it to a piece of rough. Finally, let's return to the print panel. Here, we can review the generated faceting diagrams and check the design information we entered earlier. We can still update the title, author, comments, and other design details before printing. Once everything looks right, click Print. GemSim generates a PDF containing the diagrams and cutting information ready to save, share, or use at the faceting machine. And that's the complete workflow. Starting from an existing faceting diagram, we recreated the Three Muses by Mark Oros